I'm not going to spend too long going through the first principles of this, but if we're trying to find the area of a sector of a curve and it's defined as polar coordinates, then our formula for the area of the sector of the curve is A is a half between our two angles, alpha and beta, of r squared d theta, when the area is bounded by radii alpha and beta. It's much easier to explain, I think, kind of looking at one of the examples. Again, I would highly recommend you scanning these and kind of seeing what comes up. It's a good few examples of what's going on here. What we're going to do is find the area of one loop of the curve r equals a cos 3 theta. Now hopefully if your memory serves you well, if you look back in your notes, we're dealing with this shape here. So we want to find the area of one of these three loops. So we're going to find the area of this one, and you can see then it's in between minus pi over 6 and pi over 6. So that's where we're going to be integrating in between. So we'll write that down then. So I've written then in kind of my notes. I might flick over to the actual notes in just a wee second, but one loop is bounded by tangent lines. Theta is pi over 6 and theta is minus pi over 6, and again I've written in see the example then for that. Therefore the area that we're looking for is a half in between pi over 6 and minus pi over 6 of r squared d theta, and in our particular case minus pi over 6 or r squared, or r of course is a cos 3 theta, so r squared is going to be a squared cos squared 3 theta d theta. The way we would differentiate that, integrate that, is to use our double angle formula, because we have a cos squared there, so we need to change that out. Again, I'm not going to spend time doing that now, that's part of your A level notes. So using double angle, we have then area is a half, and I'm going to then take out the a squared out the front because it's not going to be in any part. Pi over 6 minus pi over 6 a half upon cos 6 theta plus 1 d theta. If you have no idea where that comes from, I'd be looking at my A level notes to make sure you can see how to change it. If you want to integrate something like cos squared, you need to use your double angle formula and change it into something that's going to be more easily integrable. That's going to give me a squared over 4, so I've taken the half out here again, and then integrating this is going to give me a 6th sine 6 theta, integrating the 1 plus theta. That's in between pi over 6 and minus pi over 6. Subbing in all my values then, a squared over 4. Subbing in pi over 6 and minus pi over 6, it just gives me pi over 6 plus pi over 6, because this will all disappear. If you do pi over 6 to sine pi, then I think it's going to give us 0, isn't it? Pi over 6 plus pi over 6 should be 2 over pi over 6, or if you want pi over 3. So I just end up with a squared pi over 12. So the area of one loop is then a squared pi over 12. Incidentally, it's just worth it we mention now, you could of course have integrated in between 0 and pi over 6 and then times your answer by 2 at the end. That's also going to be, because there's a line of symmetry there, that should also make it work.